We are recording today, ladies and gentlemen. Now, today we're going to talk about some several reactions, and we're going to write balanced equations to classify each one. What we're going to do is that we are going to go through the 6 types of reactions that we've been talking about. We're going to create their skeletons that we're going to use so we can, when we see a reaction, we can identify it as one of the 6 reactions. Your homework for this evening will be front, just front. The back is a makeup. Now, on my piece of paper here, you will see that at the top says identify the following reaction as either synthesis, decomposition, single replacement, double replacement, combustion, or neutralization. Now, we've talked about a couple of those. We have not talked about all of them. That's our goal today, is to chat about which ones are which. My hope, my dream for today is by the end of the day, you should be able to eyeball, be able to take a look at a formula and be able to identify it. Is it a combustion, a synthesis, a decomposition, single replacement, double replacement, or neutralization just by looking at it? So, quick thing, let's talk about the background here. We can represent a chemical reaction by writing out the chemical equation in which a substance is present before the reaction occurs. Those are my reactants. Are shown on the left of an arrow, and the chemicals formed by the reaction. Products are shown on the right side of the arrow. The arrow indicates the direction of change and reads as yields or produces. You may have heard me say a lot of times, this and this will then yield this. Very similar to will form. We've seen that a lot more often in our word equations. You'll see it as yield, produces, will form, or will react to form. Something to that language tells me that represents my arrow. My reactants on my left-hand side, my arrow points towards my products. Chemical reactions involve the rearrangement of the ways the atoms are grouped. It's important that we understand that atoms are neither created nor destroyed in a chemical reaction, and that's based off of the law of conservation of matter. We talked about the law of conservation of matter all the way back in Unit 2, when we went through our different, when we went through our different, what were we doing at the time? Looking at the different scientists and their understanding of what the atom was. All atoms must be accounted for. You've already been doing this, which is great. In other words, there must be the same number of each type of atom on the product side as the reactant side. Now, often, we've seen this come up a couple times where we see the physical states of each substance is specified in the reaction. We saw that we've seen things like the AQ. We've been talking about our acids, right? For aqueous. It means it's dissolved in water or it's in some kind of aqueous solution. If we see an L, it stands for liquid. I know we've seen the G for gas, and we may have seen the S for solids. It's just telling me the states of matter that the substance is in. As I go through my chemical reaction, sometimes, like we saw in the last lab, I had 2 liquids, and every once in a while, they formed a solid. We had a change in the physical matter. Just because it's in one form doesn't mean it stays in that form. So, it's something that you've seen. We're just putting it to paper as, hey, this is what they mean. So let's talk about our 6 types of reactions. The first one is our synthesis reaction, also known as a combination reaction. This reaction occurs when multiple simple reactants combine to form a complex product. The way I can always tell if I'm looking at synthesis reaction versus the other types of reaction is that there's always only one product that's formed. Often, when we say simple, we mean an element. One element interacts with another element, and that's going to form one product. Now, if I look to my homework, so I want you to have this other sheet handy and available to you. If I look at my homework real fast, and I look at number 1. Number 1, I see one product, one element will react with each other to form one product. Number 1 is a great example of a synthesis reaction. An element and an element form a product. Very similar to what my skeleton is. One element plus another element gives me one product. A decomposition reaction occurs when we have some kind of compound reacts to break down into simpler, smaller products. How I can tell my synthesis from my decomposition apart from each other is where synthesis started off with ended in one product. My decomposition has one reactant. I'm going to have some kind of compound, and that's going to break down to simple compound or element. And another simple compound or element. I have something big being broken down into something smaller. If you look at your homework real fast, could you point me to a number that represents a decomposition reaction? 2. 2's a great one. Why? I have one compound breaking down into smaller parts. One reactant, multiple products. How are we feeling so far? Feeling good? Okay. Experiment number 3, we're talking about a combustion reaction. This reaction involves what's known as a hydrocarbon, so it's a compound containing both hydrogen and carbon, reacting with oxygen. Their products are always carbon dioxide and water vapor. Think about like a fire. In order for combustion to happen, I need something carbon-based. Woods are normal. Wood, sticks, leaves. Unfortunately, in some cases, a home catches on fire. Either way, the majority of it is carbon-based. So we have our hydrocarbon. We've seen that, CH. It's going to interact with oxygen. And that's going to produce carbon dioxide and water. And the water that's formed is in form of gas as vapor. Never have I ever struck a match and felt water droplets on my hand, right? Yeah, when I sit there and I strike a match, right, guys? We've done this a couple times in labs. Never did I have a bunch of water droplets fall on my hands, right? No. The water's vapor, but the water's there. It's important for us to know that. Because in the quiz today, also with some other stuff that you're going to see, when I give you a word equation, I go, hey, this formed carbon dioxide and water vapor. Some of you may be asking me, hey, Mr. Wiseman, what's water vapor? It's just water in gas form. That's all it is. But these are the skeletons that we're going to use to identify our different types of reactions. So let's go back to our homework. And I would like for you to give me a number that is a combustion reaction. What is an example of a combustion reaction? We know it's not 1 or 2, right? What's another one that starts off with some kind of hydrocarbon, carbon and hydrogen, interacting with oxygen to create oxygen and water? 7. Sorry, not oxygen, carbon dioxide. 7 is a great example of a combustion reaction, right? I got my hydrocarbon interacting with oxygen, reacts to form carbon dioxide and water. Looking good so far? All right. Well, here things are going to get just a little... The most complicated items are on the backside. Okay. So now we're getting into our replacement reactions. Now in our replacement reactions, we have talked pretty hard about double replacement reactions. It's what you had your lab on, right? It's what you turned in to me today. So let's start with double replacement reaction because that's the one that we know better. Double replacement, the formation of a solid when 2 solutions are mixed is called a precipitation. This reaction requires the reactants of 2 ionic compounds dissolved in water that rearrange to form at least one new solid ionic compound. This occurs when a cation from one compound bonds with the anion of another compound to form an insoluble compound. Now, I don't like the term, the idea double date gone wrong. I like the idea that we are changing dance partners. Nobody wants a date to go bad, right? But we've all been to a dance before. Maybe you've gone to a wedding or something like that. No one just dances with one person the entire time that they're there. Usually you're going to change it up. You're going to dance with somebody else. For my juniors and my seniors that are out there, prom is right around the corner. You're going to go with somebody, hopefully. If not, you always go by yourself. There's plenty of single people that are going to be there as well. And you're going to dance with the date that came along with you, the friends that are there. You may find someone else that you're going to hang out with. There's all sorts of stuff. You're going to interact with other people. You're going to change dance partners. You might be upset because someone's dancing with somebody you want to dance with. And you look better than that person. You want to know what that other person was thinking this entire time. They thought they were going for a huzz. They found a chuzz. Chuzz is the bad one, right?
Yes.
See, I'm up on the TikToks. I know what's going down in the streets. But we saw this pattern before. AB plus CD yields BC plus AD. We talked about them being ionic compounds. Remember, in my ionic compounds, my cation is always written first. So my A and my C are my cations. My B and my D are anions. A and B, C and D went together to prom with each other. At some point, A and D are going to start dancing with each other. At some point, B and C are going to start dancing with each other. Now, A and C will not go dancing with each other because they're both positively charged. Because they're both positively charged, they're going to repel from each other. So I will never see a combination of A and C. Same reason why I won't see a combination of B and D. They're both negatively charged. They're going to repel from each other. All we're doing is changing those dancing partners. If you want to get literal with it, it would be really CB, because C is my cation. But it looks better when we read it that B goes before C. So if you need it written exactly, if I was going to go, if I had a reaction and I was to write A, B, C, D underneath it, and I did not, and I made a mistake in my products where I put the anion in front of the cation, technically it's written it's going to be CB plus AD or AD plus CB. There's no rhyme or reason to which order they're in. The fact is that they're changing the dance partners. Looking at my homework, what's another example of people changing dance partners?
I want to say 8.
Yeah, 8's a good one. Because if 8 is A, B, C, D, I see A and D for my silver chlorate, C and B for my sodium nitrate. Do you see that? So that's my double replacement. Now let's go into our single replacement. So a single replacement reaction occurs when one reactant can be an element and the other is going to be a compound. The atoms are going to rearrange so that the element pushes out either the cation or anion and takes its place. Now, your paper says to think of it as a love triangle. I don't have another good way to put it, another good imaginary way to look at it. But I will tell you this, there's always going to be some kind of compound, right? So there's going to be compound AB, and then we have C. And depending on the charge of C, it's going to determine what it kicks out. If C is a positive, or what is usually a cation? Metals or nonmetals? Typically they're metals, right? A and AB would be the cation. If I have a single element cation, it's going to replace my A. If I C, my element, is negatively charged. What would that mostly be? Would that be a metal or non-metal if it's mostly negatively charged? Yeah, usually non-metal. So my non-metal. Or my polyatomic ions. Then it's going to be the anion that gets kicked out. So it depends on which one is which. Some element is going to be positive or negative. And they're going to replace what's there in the compound. So if I went back to my homework here, could I identify a single replacement reaction? What would be an example of a single replacement reaction here? Do you think it could be 3, 4, 5, 6, or 7? 3. I have the zinc metal, right? Metal is typically a cation or anion. Are metals positively charged or negatively charged? They're usually positive, right? Metals make it the majority of the periodic table, wish to get rid of those electrons, not hold on to them. Here I have sulfuric acid interacting with zinc. When zinc is in the presence of sulfuric acid, it's going to kick off the hydrogen and replace it, and now it's zinc sulfate. Only one thing is being replaced, the hydrogen, i.e. single replacement. When I look at 8, the nitrate and the chloride are swapping cations. Single, double replacement. The name gives you the answer that you're looking for. Either I have one thing, single things being replaced, or I have two things, double replacement. That's how I'm going to tell the two apart from each other. Now, we have one last one that we have to look at. Acid-base reactions, also known as neutralization reactions. So this is a special type of double replacement reaction. That's why I spent a lot of time talking about double replacement, because we deal a lot with it. And the majority of the type of reactions that we see on a regular basis tend to be double replacement reactions. Double replacement reactions that create water are called acid-base reactions. These happen when one reactant is an acid, which has an H for a cation, and the other reactant is a base that has a hydroxide unit as an anion. So, our basic structure for this is going to be H next to some kind of acid. Remember, how I write my acids, there's always a hydrogen up front. Whether I'm talking about hydrochloric acid, whether I'm talking about chloric acid, whether I'm talking about chlorous acid, I always start off with the hydrogen up front, right? That's going to interact with some kind of base that has an OH group attached to it. This reaction like we said, it's a double replacement. So we got positive hydrogen. We got a minus A, negative A. We have a positive B. We have a negative hydroxide group. My hydrogen and my hydroxide unit are going to interact with each other to form water. And that leaves my B and my A to be my other product. What we are going to do, or what we should be able to do, maybe not after today, but definitely after Friday, that if I were to give you the reactants of some kind of equation, you should be able to tell me what those products are based off the 6 different types of reactions that we looked at today. If I had a situation where I had calcium sulfate and barium nitrate, and I said they interacted with each other to yield something new, you should be able to tell me that's going to be a double replacement reaction. Now, obviously, I'm saying it out loud so you guys can't see the actual reaction in front of you. But if we put these skeletons to memory, there's nothing I can throw at you for the rest of this year that should shake you. These skeletons are going to make up a huge backbone of what we're going to do for the rest of the year. For those who need the SOL, these skeletons are going to be a great source of help for you and will make or break your time in stoichiometry, which is the very next unit that we get into the week after we come back from spring break. Stoichiometry is going to be, I think it's like a 2-3 week long unit, and then we get to ideal gas laws, and then we'll start getting into unit 10 right before SOLs. As of right now, we probably will not make it to thermodynamics. Now, those who are going to physics next year, if you've talked to your counselor and you specified, hey, I want to do physics, Mr. Jeffries and Mr. K are aware that a lot of us do not make it to thermodynamics. It's a tool that's going to help you out later in physics, but if we don't get to it, it's not the end of the world. You'll pick up that tool while you're in physics. But what I want you to do is I want you to take some time right now. I got 8 minutes until we start the quiz. If you would like this 8 minutes to review your balancing equation sheets, I gave you, you had your homework before. You had the balancing equation. So another good source that you'd be looking at, if you are not great at your being able to read the name of a compound and then write its formula, you might want to take a look at this sheet again. I gave you all a copy. You might want to look at it. Ma'am. Sure. You may also want to take a look at your balancing sheets. And you also want to make sure you have a periodic table in front of you. I'm going to come around and drop the periodic tables off to you. Yeah, it's a little bit of compensation from the cleaning. You. So you have one. Jasmine. You have one too. Do you have one? Yeah, it's just when they come in and they write down the tables, if there's stuff on it, they push it around. So water gets trapped underneath it. It happens. I am going to ask the sports school this year. I'm okay with it outside of the back. Usually we're a little bit of separation.
I just hope there's no like super complex ones. I don't want to Like this specifically? Wait, what is it?
No. So I will warn you on the quiz, there are 4 word problems that you're going to have to convert into the formula and then balance said formula. Angela, can I have you slide in over a little bit? Jasmine, Janelle, can I have you guys slide in this a little bit so like people on the edge have a little bit more space?
Like right here?
Yeah, just slide. Hayden, can you slide over a little bit? Hayden, would you want to take this quiz? Let's get you there.
Guess so.
There we go. Well, you can start a little bit more because Hayden's gonna he's gonna take our stuff over to the side.
Why don't we just leave my channel? This is my desktop. Just do it for this video. So folks, so
Thank you. All right. But yeah, you're gonna have a mixture of me giving you a word problem where you're going to create the formula, balance that formula. Other times, I'm gonna give you the formula, and you're just gonna have to balance the formula. If you'd like an extra sheet of paper, that's why you can write your atoms or polyatomic items underneath the arrow. I'm gonna have the paper over here. You are welcome to grab yourself a blank piece of paper to help you out, if you'd like one. It's there for you. Excuse me. Oh, I didn't know how to do so. Ow. But like I said, I'm gonna let it ride till 9, and then we're gonna get started. Well, no, everyone here shouldn't be. I shouldn't have to worry about the SOS because everyone here, if you were in SOS, you'd already be downstairs doing the SOS. Yeah, sophomore, something to look forward to next year. For my junior, she's already taken your writing SOS so far. How'd you do? How do you think you did?
Good.
All right. Positive thing. I like that. All right. Eric's here, Hayden's here, Janelle's here.
Huh?
Isabel isn't, Marisol is, Jackson is, Sean is not, Lucia is, Kelsey is, Giselle is, Jaden's not, Abigail is, Angela is, Manuela is, Larry is, Precious is, Zach is, Juan is, Jackson is. Alright. So all this is going on here.